Okay, class, we're going to do A Math Chapter 6. For Chapter 6, we'll only be doing the exponential equations part. We don't have to do the logarithmic part. Okay, so it's out of the syllabus. So for this part is only here. Okay, exponential equation is only this part here. Okay, the rest don't have to do. So this chapter, even though it's up to 6.4, 6.5, okay, but we only need to do 6.1 and 6.2. Okay, so now exponential expressions and equations, what do we mean by exponential? Okay, you learn in E-math, right? Exponential is actually the index, or what we call the power, and you also know that this is called the base. Okay, 2 to the power 3 equals 8, so this is called the base. Okay, and this is called the power or the index. Okay, or index or exponent. That's why we call it exponential equation. So anything that has the power, okay, we call it the exponential equation. Okay, so you have also learned in indices that the various identities, like a to the power 0 is 1, then negative index a to the power negative n is 1 over a, and okay, and then fractional indices like square root is power half, cube root is power 3. So all this you have learned in E-math. And also the 5 laws of indices, when you have the same base, okay, you add up the power, okay, and then when the sign is multiplication and when the sign is division, you minus the power, okay, and then if you have a to the power m to the power n, then you times the power. Okay, so and then the fourth rule would be, if you have the same power, you can actually group the power together, right? So a to the power x times b to the power x equals to ab to the power x. So all these are your laws of indices and your identities, so you need to know them. Okay, and then we proceed on from there. Yeah, okay. Okay, before I do that, now we need to correct this because there's a change in your date, right? Okay, this is no longer term 2, right? So this is term 3, week 1, okay, and 3 and 1. Yep, so today is the 2nd of June. Okay, example 1, okay, without using a calculator, simplify the exponential expression 1 over 27 to the power of negative 3 over 2 times square root of 3 to the power of 3 and divide by 9 to the power of 4. So you observe the three terms, okay, the common base would be base 3, so you try to change everything to base 3. Okay, so within the brackets, yeah, 1 over 27, okay, is actually equals to 1 over 3 to the power of 3, right? So it's actually 3 to the power of negative 3. So this is 3 to the power of negative 3, and then to the power of negative 3 over 2. Okay, so that's the first term. Then times, okay, square root of 3. So square root of 3 is actually 3 to the power of half. Okay, remember your indices? Okay, so this will be 3 to the power of half inside the bracket, and then the power of 3, and then divide by, okay, 9 is actually 3 to the power of 2, and then to the power of 4. Okay, so and then you simplify using the law of indices. Okay, so this will be 3 to the power of 9 over 2, okay, times 3 to the power of 3 over 2, and then divide by 3 to the power of 8. So your law of indices says that you will add the power, okay, when it's multiplication, and minus the power when it's divide. Okay, so this is actually 3 to the power of negative 2, so simplify it, 1 over 9. Yeah? Okay, the next one, try one. You can try on your own first, okay, or you can just follow. Now, without using a calculator, simplify each of the following exponential expressions. So again, you observe, okay, for A, right, the common base that you would think about would be your 7, right? So you simplify every term. So this will be within the bracket 7 to the power half, right? Square root 7, power 3, then times 7 to the power 3, 3 for 3, yeah? And then to the power of negative 3 over 2, divide by 7 to the power of negative 2, because it's 1 over 49, power 2. So this is 7 power 3 over 2 times 7 power negative 3 over 2, divide by 7 to the power negative 4. So it's 7, 3 over 2 plus negative 3 over 2, and then minus 4. So your final answer is 7 to the power of 4. So what is 7 to the power of 4? 2401. Okay, question B. Right, now B, All right, you notice, okay, observe, it's slightly different from the other sum, but then still, okay, all you need to do is to find the common base. Okay, so in this case, it's not hard to realize that actually 3 is a common base, so you convert everything to base 3. Okay, so this sum is going to be a bit long. Okay, so be very patient. Okay, so, right. So 81, now 81 is actually 3 to the power 4, right? Okay, so this is 3 to the power 4 power x plus 1 minus 3 to the power 2 2x plus 1, okay, over 3 to the power x minus 4, and then times 3 to the power 3 x plus 2. So everything, you change it to base 3. Okay, then this will be 3 to the power of 4x plus 1 minus 3 to the power of 4x plus 2. Okay, over 3 to the power x minus 4 times 3 to the power 3x plus 6. Okay, so the next part, what you need to do is to see how you can simplify everything. Okay, so in this case, all right, you look at your numerator first. Okay, so your numerator here, you notice that there's a common factor. It's actually 3 to the power 4x. Okay, so it's 3 to the power 4x. Then the first term will be 3 power 1, then minus 3 to the power 2. Okay, so you factorize the 3 to the power 4x out. Okay, so remember here, 3 to the power 4x times 3 to the power 2, because same base, right? So it's 3 to the power 4x plus 2. Okay, that's how you get your 3 to the power 2 here. Okay, then you divide. Okay, then we look at the denominator. So in this case, it's times, right? So it's times, so I can add the power. So x minus 4 plus 3x plus 6. So that's 4x plus 2. Oh, okay, so I have common. So I have 3 to the power 4x in the numerator. Then 3 minus 9. 3 minus 9 is minus 6. Okay, then over, okay, 3 to the power 4x times 3 to the power 2, right? Split it up. Why do I want to split it up? Because I want to cancel out the 3 to the power 4x. See, it is done. So your final answer here, okay, would be negative 6 over 9, which is negative 2/3. Yeah? Okay. Okay, let's go on to further example. Okay, example 2, right? 5 to the power 2y times 3 to the power y equals 1 over 75. Okay, so in this case, you notice that your bases are on the left hand side, 5 and 3, they are different bases. Okay, and then you're supposed to solve for y, right? But the power is also different. So what you can do is that you have 5 square, split this out like this. Yeah, so you have actually 25 to the power y times 3 to the power y equals to 1 over 75. Okay, then you notice that 25 to the power y times 3 power y is a common power, right? So when it is a common power, it is actually equals to your 25 times 3 to the power of y common power. This is equals to 1 over 75. Okay, 25 times 3 is 75. Okay, so 75 to the power of y equals to 1 over 75. Okay, 1 over 75 is 75 to the power negative 1. Comparing, right, because the base is the same, right? So therefore, y must be equal to negative 1. Right, now b, so you're supposed to find z. So simplify 1/3, so 3 to the power negative 1. So negative z minus 1 plus 3 to the power half times 2z, power 2z, so equals to 36. So this is 3 to the power of z plus 1, okay, plus 3 to the power of z equals to 36. Now please do not add the power because the sign here is plus. So when the sign here is plus, you need to factorize. Okay, so 3 to the power of z plus 1 plus 3 to the power of z, common factor is 3 to the power of z. You factorize it out. So the first term you will have 3 power 1, then plus 1 equals 36. So 3 to the power of z times 4 equals to 36. So 3 to the power of z equals to 36 divided by 4, that's 9. So 3 to the power z equals to 3 to the power 2. 9 is 3 to the power 2, right? So therefore, same base, right? So z must be equals to 2. Okay. Okay, try 2. So you can try your 2 on your own, A to D on your own first, and then you check your answer. Okay, you can pause the video for this moment, right? So, or you can just follow. Okay, 2 to the power 2a times 3 to the power a equals 1 over 44. So again, you notice that I can change 2 to the power 2a to 4 to the power a. Okay, so 4 to the power a times 3 to the power a equals to 1 over 144. So this is 12 to the power of a, common power is 144. So 12a equals to 12 to the power negative 2. So a must be equals to negative 2. Okay, and then b, 100b is equals to 1 over 1000. So 100b is actually 10 to the power of 2b. And this is equals to 1 over 1000 is 10 to the power negative 3. So 2b, compare the indices now, is equals to negative 3. So b is equals to negative 3 over 2. Okay, so quite easily done. Okay, the next one. Okay, the next one. Yeah. 3 to the power n minus 3 to the power n minus 2 equals 8 over 3. So, okay, so basically your 3 to the power n minus 3 to the power n minus 3 is actually 3 to the power n divided by 3 squared. Okay, so this is equals to 8 over 3. Okay, so this is 3 power n minus, okay, 1 over 3 squared is actually 1 over 9. So it's 3n over 9 equals 8 over 3. So I can factorize 3 power n. So I'm left with 1. This is 1 over 9. This is 8 over 3. So 3n to the times 8 over 9 equals 8 over 3. Okay, so 3n equals to 8 over 3 times 9 over 8. Right, cross multiply. So 3 power n is equals to 9 over 3 is 3. So comparing your indices, n must be equals to 1. Okay, got it? Write things through, yeah? And finally, D, 6 to the power 1 minus x squared equals to 1. I'm supposed to find x, right? So how do I actually have a common base so that I can compare the indices? So on the left hand side is 6 to the power 1 minus x squared. So 1 is definitely not the common base, isn't it? So how do I change 1 to base 6? So you have learned a lot of indices, you have learned the identities as well. Okay, so 6 to the power of 0 is equals to 1. Okay, because it's the same base, right? So now you can compare the power. So therefore the power 1 minus x squared is equals to 0. So x squared equals to 1. So x equals to plus or minus 1. Okay, so quite easily done. Okay, example 3, simultaneous exponential equation. So now instead of just one exponential equation, we have two. Okay, so how do we actually solve this? Okay, what we need to do is to reduce the two equations to linear equations involving x and y. Okay, so we take the first one first. Okay, 2 power x times 4 power y equals to 1 over 8. So again, your common base will be 2, right? So this will be 2 power x times 2 to the power 2y equals to 2 to the power negative 3. So using a lot of indices, you have 2 to the power x plus 2y equals to 2 to the power negative 3. So this is therefore same base, right? So x plus 2y must be equals to negative 3. See, you have converted your exponential equation to a linear equation. Okay, then the second one, 9 to the power x over 3 power y plus 1 equals to 27. So 9 to the power x is 3 to the power 2x. Okay, over 3 to the power y plus 1 equals to 3 to the power 3. So this will be actually 3 to the power 2x minus y minus 1 equals to 3 to the power 3. So, okay, the same base again. So therefore, the indices is 2x. Okay, minus y minus 1 is equals to 3. And you simplify it to have 2x minus y equals to 4. Okay, so you have two equations, linear equations, okay, which you can solve easily. So you can either substitute x or you can substitute y. So here, okay, what I can do is that x equals to minus 3 minus 2y. Okay, so I call this equation, okay, this is equation 1, this is equation 2, and this is equation 3. So I can substitute equation 3 into equation 2. Okay, so I will have 2 minus 3 minus 2y minus y equals to 4. This is minus 6 minus 4y minus y equals to 4. So 5y equals to minus 10. So y is equals to negative 2. So if y is equals to negative 2, therefore x will be, you substitute back into equation 3, minus 3 minus 2 times negative 2. This is minus 3 plus 4, 1. So your final answer, x equals to 1 and y equals to negative 2. Okay? Right, so I want you to try 3, and then you check for your answer. Okay? Okay, so let's look at the next part here. So this is actually 2 to the power of 3x. Okay. Over 2 to the power y plus 1 equals to 2 to the power 3. So this is 2 to the power 3x minus y minus 1 equals to 2 to the power 3. So this would be 3x minus y minus 1 equals to 3. 3x minus y equals to 4. Okay, so this is equation 1, this is equation 2. So I can simplify equation 1 to x equals to minus 1 minus 2y. Okay, so I substitute equation 1 into equation 2. So I will have 3 minus 1 minus 2y minus y equals to 4. So this is minus 3 minus 6y minus y equals to 4. Okay, so 7y equals to negative 7. So y equals to negative 1. Therefore, x is equals to negative 1 minus 2 times negative 1. So it's negative 1 plus 2. So it's 1. Okay? So x equals to 1 and y equals to negative 1. So easily done. Okay, the last example, okay, will be different from the others. Okay, so just read the question carefully. The equation of a curve is given by y equals to k times a to the power x, where a and k are constants. Okay, given that the curve passes through the points 2, 16, 3, 32, and 5p, find the values of a, k, and p. Alright, so they give you the clue, isn't it? They give you 3 points, and they say that these points lie on the curve. So if these points lie on the curve, it means that it satisfies the equation. So you substitute. Okay, so you substitute 2, 16. So y is 16, right? Okay, and you have k a squared. Okay, so you have one equation. Then you substitute the next point, which is 3, 32. So y is 32, and then k a to the power of 3. Okay, so you have these two equations. Now, you observe, okay, what can you do? Okay, what can you do? Right, so this is equation 1, this is equation 2. So you notice actually you can get rid of k, isn't it? So all I need to do is that I use 2 divided by 1. So equation 2 divided by equation 1. So that's 32 divided by 16 is equals to ka cubed divided by ka squared. So this would be cancel. Okay, so this is 2 equals to 8. So straight away, I've got a equals to 2. Now, once you've got a equals to 2, you should be able to find k. So you sub this, right, back into equation 1. Okay, right? So equation 1 is this, right? So 16 is equals to k. A is now 2 and square. So 16 is equals to 4k. So k is equals to 4. Okay, so I've got a and I've got k. So finally, how do I find p? So you substitute, okay, 5p into y equals to kax. So you know that k is 4, right? And a is 2. So therefore, y equals to 4, 2 to the power x, right? So now, okay, p is this, okay, p is y, right? And then x is 5. So this will be 4 times 32. Okay, 4 times 32 is 128. Okay. Okay, so classwork. So I want you to do the exercises here. Okay. This one. Okay, do it on foolscap neatly. Alright. And hand it in by today. Okay, 10 p.m. Okay, send it to me. Okay, please do not be late. Yeah, and then we'll go through it. Right?